Hey friends, welcome. Today we will be discussing one of the topics again from quantum chemistry, and that is a particle in three-dimension box, which is again one of the solutions of the Schrodinger wave equation. In our previous topic in quantum chemistry, we have discussed the particle in one-dimension box. So basically, one-dimension box is along any one axis, and over here three-dimensional box we will be considering it is a three-dimensional box, and the particle is confined in a three-dimensional box. So suppose if we are considering that this is a three-dimensional box whose length along x-axis is a, along y-axis is b, and along z-axis is C, and we are considering that we have a particle, or suppose we have an electron which is free to move inside this box along any particular axis, and inside the box we know that the particle will not experience any amount of force, and as a result the potential energy inside the box will be zero, and the potential energy on the walls as well as potential energy outside the wall will be infinity. And as the potential energy outside the walls is infinity, or on the wall as well as outside the wall is infinity, the particle or the wave function will be zero, as we have seen in our previous video. And as a result the particle will not exist outside the box, but the particle will only exist inside the box. Okay, and inside the box along x-axis, suppose we can write that the potential energy V is the potential sum of the potential energy along x-axis into potential energy along y-axis plus potential energy along z-axis, and along all the axis, that is potential energy along x-axis will be zero under the condition that the particle lies between 0 to a. Potential energy along y-axis will be 0 for the condition where the particle will lie inside, or it is between 0 to b, and similarly potential energy along z is 0 when the particle will lie between 0 to c. Okay, and we are considering that the walls are perfectly elastic as well as the walls are impermeable, that is it will not allow the particle to go outside the box. Okay, so this is the condition, and over here as we are considering that the particle is inside the box and we have three dimensions, we will be using the Schrodinger wave equation for three dimension, that is Schrodinger wave equation, that is del square psi by del x square plus del square psi by del y square plus del square psi by del z square plus 8 pi square m by h square into we will have e minus v, and that is equal to 0. So this is the Schrodinger's wave equation, and again if we use, or for the condition when v is equal to 0, we could substitute v is equal to 0, and hence our expression will become equal to 0. So this will be the expression when we are considering the potential energy is 0, that is the particle is present inside the box. Into we have psi also over here. So now for different books they have different derivations. Now I am deriving one of the most simplest way in which we could obtain the solution. Now again we will be obtaining the value of energy as well as we will be obtaining the value of the wave function in this expression. Also we will be looking at degeneracy at the end of the video. So this is our Schrodinger wave equation, and we know that this is psi is the wave function. This wave function, it depends on the coordinates x, y and z. So we will be separating the coordinates, and hence we can write that psi, it is dependent on x, y and z. So this we could separate it into the coordinates, that is psi of x into psi of y into psi of z, where psi of x is the wave function that is dependent only on x, psi of y is the wave function that is dependent only on y, and psi of z is the wave function which is dependent only on z. Also, the total energy is will be the sum of the energy of the three components, that is the total energy E. I could write it as energy along x-axis plus energy along y-axis plus energy along z-axis. So the total energy again, it is the energy along the three coordinates, that is x, y, z respectively, and as a result it could be represented in this particular manner. Okay, now we can double differentiate this expression, once with respect to x, next time with respect to y, and another time with respect to z. So when we differentiate this expression with respect to x, then we will have d square psi by dx square is equal to, now both this is constant, so we will have psi y into psi z, and we will have d square psi x by dx square. Similarly, when we differentiate it with respect to y, we will have d square psi by dy square, we will have psi x and psi z d square psi y by dy square, and d square psi by dz square is equal to psi x psi y into d square psi z upon dz square. Okay, so these are the three expressions that we have obtained. So this three expressions, that is 1, 2 and 3, these three expressions could be substituted in this, because we have d square psi by dx square, and that is equal to this particular. Similarly, d square y by d square psi by dy square is this, and d square psi by dz square is this. So we will be substituting those, and hence we will have dz square plus, so now we have 8 pi square m by h square plus e into psi. So we will have 8 pi square m by h square. E, I could write it as ex plus ey plus ez, and psi again I could write it as psi of x, psi of y and psi of z, and that is equal to 0. Now this psi, or I will be dividing whole equation, we will be dividing the whole equation by psi of x, psi of y and psi of z, and the energy term, that is this, we could multiply with energy, and x I will write with x, y I will write with y, and z I will write with z. So we will be dividing the whole expression with psi of x, psi of y and psi of z. So this 3 will be cancelled out, and we will have 1 upon psi x into d of psi x by dx square plus 8 pi square m h square into ex plus 1 upon psi of y d square psi x by psi y by dy square plus 8 pi square m h square d of y plus 1 upon psi of z d square psi z upon dz square plus 8 pi square m h square into ez, and that is equal to 0. Okay, so I have divided the whole expression. So this term will be cancelled out from energy, and this energy I have multiplied with ex I have multiplied with I have taken it with the psi x term, ey I have taken it with psi y term, and ez I have taken it with psi z term. Okay, now as the whole expression is equal to 0, the individual terms are also equal to 0. So when this individual term, that is when this bracket will be equal to 0, when this bracket will be equal to 0, and when this bracket will be equal to 0, then and then only the whole expression will be equal to 0, and hence these three independent terms are equal to 0. Also, this term, it is only dependent on x, this term is only dependent on y, and this term is only dependent on z. So we could write these three terms independently, and hence we will have 1 upon psi x d square psi x by dx square plus 8 pi square m ex upon h square, and that is equal to 0. Similarly, the second term is psi y d square psi y by dy square plus 8 pi square m ey upon h square, and that is equal to 0. And the third term is psi z d square psi z upon dz square plus 8 pi square m ez upon h square, and that is equal to 0. So these are the three expressions, and these are independently equal to 0. Now from these equations are the second order differential equation that we have solved for the particle in one dimension box. Okay, so these are the similar, or these are the same differential equations that we have solved for particle in one dimension box, and hence that solution we could directly apply to these three expressions. And as a result, the first expression, it represents the energy along x-axis, second energy along y-axis, and third energy along z-axis. So hence the energy, that is Ex, it will be given as n square x h square upon 8m a square, where n square x is the principal quantum number along x-axis, h is Planck's constant, and m is the mass, and a is the length of the box along x-axis. And similarly, the wave function along x-axis, it will be given by under root 2 by a sine nx pi x by a. Similarly, the solution for the second expression, that is energy along y-axis, will be given as n square y h square upon 8m b square, and the wave function along y-axis will be given as under root 2 by b sine ny pi y by b. And similarly, energy along z-axis will be given as n square z h square upon 8m c square, and the wave function along z-axis will be given as under root 2 by c sine nc pi z by c. Okay, so these are the energies along the x-axis, and similarly this represents the wave function along x-axis. So, and we know that n are the principal quantum number, and n values are from 1 2 3 and up to infinity. Okay, so the total energy, as we have seen, that the total energy will be equal to energy along x-axis plus energy along y-axis plus energy along z-axis. So hence the total energy of the system, it will be given as n square x h square upon 8m e square plus n square y h square upon 8m b square plus n square z h square upon 8m c square, and we could take h square upon 8m common, so h square upon 8m common, and hence we will have n square x by a square plus n square y by b square plus n square z by c square, and this gives the expression for the energy of the particle which is performing motion in a three-dimension box, and this shows that the energy of the particle is quantized, that is, it is divided into several energy levels. Similarly, for the wave function, we know that wave function is equal to psi x into psi y into psi z, and hence we will have under root 2 by a sine, under root 2 by b sine, and under root 2 by c sine. So this we could combine it, and we will have under root 8 by a b c sine nx pi x by a into sine nx ny pi y by b and sine nz pi z by c. Okay, so this is the wave function which corresponds to the particle which is performing motion in the three-dimension box. Also, we know that L into breadth, so A is the length, breadth and height, so length, breadth and height, that is equal to the volume, and hence this could be written as under root 8 by V, and other things will remain as such. So ABC could be replaced in place of volume, and this is the normalization factor, and this is the normalized wave function. Now when we are considering a cubical box, then in case of a cubical box, the length, the breadth and the height of the box are same, that is, all the sides of the box are same. And suppose if we are considering that A is equal to B and that is equal to C, then for cubical box the energy, we could write it as h square upon 8m, and this and this, all these three will be same, so we could take common out, and that will be a square into n square x plus n square y plus n square z. So this will be the expression for the energy when we are considering a cubical box, and for the value of energy, that is when the value of nx is equal to 1, that is equal to ny, and that is equal to nz, that is when the value of all the three nx, ny and nz are equal to 1, at that time the energy of the system will be represented as E11, and that will be equal to h square upon 8ma square into 1 square plus 1 square, and that will be 3h square upon 8ma square, and this energy is represented as the ground state energy for the particle in three-dimensional box. So this is the ground state energy. Now further, for the second energy level, so the second energy level, it is obtained when the two of the three quantum numbers is 1 and one of the quantum number is 2, then we have a second energy level. Now this second energy level, for the second energy level, we could arrange the quantum numbers in this particular manner, that is we have this. So the energy of the system will be, this will be h square upon 8m a square. So we have 1 square plus 1 square plus 2 square, so 4 5 6, and this will be 6h square upon 8m a square. Now over here, this quantum numbers or this arrangement could be done in this manner also, 1 to 1, or the arrangement could be done in this manner also. And for all the three cases, the energy will be 6h square upon 8m a square, 6h square upon 8m a square. Okay, so over here the each states, it corresponds to the individual energy, and there are three independent states which are having the same energy. So this energy levels having the same energy, this energy levels, they are referred as degenerate. And as there are three states, this state it is referred as triply degenerate state, and that is, and the energy we could represent this as E112 energy. This could be represented as 1 to 1, and energy could be represented as 211. So there are three states having same energy, and hence those states having similar energies, they are referred as degenerate, or energy levels they are said to be degenerate. And as there are three energy levels having similar energy, they are referred as triply degenerate. If there are four energy states, then they will be referred as four folds of degeneracy, five folds of degeneracy, and so on. Okay, if we draw the energy level, then suppose over here we have energy. So this is 3 6, and all is h square upon 8m a square. Okay. Then we have 9 11 12 14 and so on. So for 3 we have only one possible combination, that is 111. So this state will be referred as non-degenerate. Similarly, for second energy level, we have three possible combination, that is 211, 121, and 112. So this state is triply degenerate. Then or three folds of degeneracy, and hence the degeneracy of this state is 3. The degeneracy of this state will be 1, as it is non-degenerate, so we have only one state. Then for next energy level, it is 2 to 1. So this third energy level, it is also triply degenerate. So this could be arranged in this particular manner, that is 1 to 2, and it is also triply degenerate, and the degeneracy of this energy level is also 3. For the fourth energy level, again it is 131, so it is again triply degenerate. We could rearrange in 133 and 311. So this could be arranged in three manners. The next energy level, that is for next energy level, the quantum numbers are 222, and this is again singly degenerate. And after that we have 1 2 3, and this energy level has a 6-fold of degeneracy, that is degeneracy of this energy level is 6. So in this way the energies, or the energy level having the same energy, or the energy level in which we could arrange the quantum numbers in different manners, this will yield different energy levels. And because different quantum numbers or arrangement, it represents the different energies, and as a result we have three energy levels. But the energy of all these levels, we have three levels, and the energy of all these three levels is same, so hence they are referred as degenerate, and the number of possible arrangements will give us the degeneracy. So the degeneracy of this energy level is 3. If we have non-degenerate, that is only one possible combination, then those energy levels are referred as non-degenerate, and the degeneracy will be referred as 1. So hope the lecture and the topic is clear. Thank you very much.